4-6 is the quadratic formula, which you should already know. You've worked with, you've used. You will need to memorize it if you don't have it memorized already. Okay. We've talked about multiple ways to solve quadratic equations. We started with graphing and looked at the x-intercepts. Then we went to square root properties, solved quadratics using square root property. We solved quadratics using factoring. Today we're going to talk about, we also solved quadratics using completing the square. Now we're going to talk about using quadratic formula, which will work every time. Okay. Ultimately, depending on what the directions or the assignment, that should dictate which method you use. But for a quadratic formula, as we know, any quadratic equation can be written in general form, standard form, ax squared plus bx plus c equals 0. To solve using the quadratic formula, we just plug in a, b, and c in the appropriate places. Does anybody remember what the quadratic formula is off the top of your head? Jessica, go.
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
Very good. Okay, yep. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to know that. Now, since this is a honors course and some of you are self-proclaimed math nerds, on the very first page in 4-6, you can see the proof of where this comes from. So when you want to get your nerd on, look at that. It's kind of cool, actually. Basically what it is, where the quadratic formula comes from, is if you solve this for x by completing the square, you get this. Okay, so that's the sort of long story short. But if you want to look at it, it's on the very first page of 4-6. It's a cool proof, and kind of shows you where it comes from. So I think that's useful, because my guess is at one point or another you wondered, where in the world did they come up with this? And it's right there in 4-6. Okay. So we're going to solve this equation using the quadratic formula. Okay, x squared plus 12x equals 9. What's the first thing I have to do? Move the 9. Why? What has to always be true? One side has to be 0. Okay, so we're going to move the 9 to the other side. X squared plus 12x minus 9 equals 0. Okay, now the next thing that I like to do, and I want you to write this down because this will help me help you should we be in that situation, is to identify a, b, and c. And write it down. A equals, b equals, c equals. That way when you go to show your work, in case you made a mistake, I can evaluate whether or not you're doing it right. Maybe you missed a sign or something like that. So in this problem, what's A? Everyone, all together. What's B? What's C? Yeah, where do you even get 7? I don't know. Okay, so A's 1, B's 12, C is negative 9. Go ahead and solve this. I want you to use your calculator to round to the nearest hundredth. We're going to do an approximation answer first. Okay, round to the nearest hundredth. Then I'm going to show you in a minute how to come up with an exact answer too. One of the questions you might have is, when do you round? Okay, and the answer is when you get what's under the radical simplified as far as you can. Okay, this is, okay, obviously we've got, this is your setup. I want you to write this down every time you do one of these problems. I realize that you can do some of this in your head and that your calculator will do a lot of it for you. But the initial setup, I want to see written out. Okay? This helps us avoid pitfalls, find mistakes if you make them. Okay? Because if there's something wrong with your setup, everything else after that is going to be wrong. Okay? And so that's going to help me, like I said, help you. So when I simplify underneath the radical, I get the square root of 180, which is not a perfect square. Okay? And maybe that's the first place you go, is you plug that into your calculator and you see if it is, because maybe you don't know. All right? But at that point, I'm going to convert the radical into a decimal. And this is where I rounded and I come up with an approximation. This is an estimate. Because as we learned in chapter 1, when you have a square root and the number underneath, which is called the radicand, when that is not a perfect square, it's an irrational number. It never ends, it never repeats. So we have to round, which now our final answer is going to be an approximation. Okay. At this point, what I'm going to do is separate the plus and minus. Okay. So I have negative 12 plus 13.42 over 2, negative 12 minus 13.42 over 2. Okay, so now I combine the tops, then divide by 2, and I get my answers. How many had those? Okay, good. What's important here is to understand that this is an approximation. Okay, it's an approximation because we had to round right here. Technically, I should have written x with the squiggly equals, but I'm not going to get hung up about that, and I don't want you to get hung up about that. Okay. I'm going to show you also how to find the exact answer, because in most of your problems that you're going to be doing, you are going to be required to find an exact answer, just like you were on your quiz yesterday. Okay? Questions so far before we go on to that? Let's look at an exact answer for this problem. Okay? So this, I'm going to start here, because this is the place where we determine whether or not, or when we go to a decimal versus when we go to an exact answer. Exact answer means you simplify the radical as much as you can. Okay. And since we know, we already figured out that 180 is not a perfect square, I have to find the biggest perfect square that goes into it and break it up into its factors. What is definitely one perfect square that goes into 180? 9 definitely goes into it. 36 is, we're going to get there. Did you just know that, or did you figure it out?
No, that's what I did before.
Oh, okay. Cool. Yeah, so let's say we didn't know 36, because I didn't know 36, and that's pretty good. But I know that 9 goes into 18, right? So I'm like, all right, 9 is a perfect square, definitely goes into it. 9 times what gives me 180? 20. Is there a perfect square that goes into 20? 4. So that's where the 36 can kind of come from. 9 times 4. 36 times what then has to actually equal 180? 5. 36 times 5. So I pull the 4 from the 20, combine it with the 9, multiply it with the 9, and then I'm left over with this 5. So what you so yes, you're right. The biggest perfect square is 36. Okay, so this is plus or minus the square root of 36 times 5 over 2. Right? This comes out. Right? Because what's the square root of 36? 6. So here's where I'm at. Negative 12 plus or minus 6 root 5 over 2. Okay? And since I'm going for exact answers, because this is what we're getting, we're going to get an exact answer, we're just going to simplify as far as we can. Now, one of the things that you can do here, because what I fear sometimes is that you guys will just try to cancel these and ignore this. And the reason why you can't do that is because in reality what this is negative 12 over 2 plus or minus 6 root 5 over 2. The 2 is under both the 12, the negative 12, and the 6 root 5. Okay, so from here, what's negative 12 over 2? Negative 6. Okay, and I still have my plus or minus, and I can reduce the 6 over 2. What's under a radical, you can only reduce with something else that's under a radical. Okay, so I can't do anything with that anyway. Obviously, 2 doesn't go into 5. But since 2 is not under a radical, you can't bring those together. But what I can do is simplify there. Okay, so that gives me 3 root 5. This is an exact answer. Okay, simplified radical form as far as I can. So when it asks for an exact answer, like your homework is going to ask you today, this is what you're going to need to do. There are going to be other circumstances, other problems, where it's going to ask you to round to the nearest whatever. And in the case of the previous slide, we rounded to the nearest hundredth. And if that's the case, that's when you're plugging that radical in your calculator and approximating it as a decimal. Okay? Questions about the distinction between the two? Okay. The second part of the lesson is the discriminant. And the discriminant allows us to figure out what type of solutions my quadratic equation is going to have. And the discriminant is just the b squared minus 4ac part. Without the square root. The part that's under the square root, that's the discriminant. So when you're asked to find a discriminant, you are not taking the square root of anything. You are just calculating b squared minus 4ac. And then, like I said, it tells you what types of solutions you should get, and we're going to talk about those different possibilities here in a sec. So the discriminant, that b squared minus 4ac, is what's under the radical. So I want to talk about all the different things that you could have under the radical and connect them to graphs, right? Because if you think about a parabola, we had three cases. Either there were two solutions because it crossed the x-axis twice, so those were two real solutions. One solution because it touched the x-axis, or we said before no solutions because it never crossed the x-axis. Now we're going to be able to talk about those two solutions when the parabola does not cross the x-axis. Because when that happens, the discriminant is negative. Meaning what's underneath the square root is a negative number. Which means if I have a negative number underneath the square root, we're talking about imaginary numbers. So therefore, there are two solutions. They are complex solutions. Imaginary solutions. In fact, those two complex solutions are conjugates of each other. When we simplified imaginary numbers, when we had a binomial in the denominator, we had to multiply by its conjugate. Those pair of complex solutions, when the discriminant is negative, will be conjugates of each other. Okay? When the discriminant equals 0, there is only one rational solution. And that's the one where it touches the x-axis. And think about it. If what's underneath the radical is 0, the square root of 0 is 0, so the sort of the plus or minus doesn't even matter anymore. Plus 0 minus 0 is the same thing. So when that discriminant equals 0, when what's underneath the radical equals 0, the solution is negative b over 2a. The radical just kind of drops out, and I get that one rational solution. It's also real, right? It touches the x-axis. So what's missing? What's left? If it's positive, like what we just did, the problem we had, what was underneath the radical was 180. That was positive. And I got two real solutions. Okay? And the same thing is true here. Okay? If the discriminant is positive, you get two real solutions. There is a sub-characteristic about a situation like this that we're going to talk about. So let's say what's underneath the radical is a perfect square. Then I'm not going to be dealing with crazy decimals or exact solutions that have to be radicals. If it's a perfect square, we can simplify it. So when that happens, if the discriminant is also a perfect square and is positive, then those two real solutions are also rational. So unlike the problem that we did for the example, they were real, but they were not rational because there was a square root in them, because we had to approximate a decimal. if it's a perfect square underneath, it's going to simplify into a rational number too. All right. So these are technically 4 different ways to describe the solutions. The discriminant. Negative, you get 2 complex. 0, 1 real rational solution. Positive, 2 reals, and possibly 2 rationals, if the discriminant is a perfect square. So here are some examples, okay? So in this one you have 2 things to do. Find the discriminant, then describe the number and type of roots. In your homework, then you will also have to solve it using quadratic, but today you do not need to solve it. For these 2 problems, in your homework you will, okay? Just work on the first one for right now. And remember, the discriminant is just the b squared minus 4ac without the radical, okay? So find that, then describe the roots, and then we'll work on question B. Yes, it is negative 19, okay? Which means there are 2 complex roots, okay? Because what's under the radical, negative 19, gives me imaginary numbers. You can't have a negative under the radical. Okay? That's all you would do for that. Now, in your homework, there's a part C. This is kind of like, this is part A, this is part B. Part C is going to say, now solve using the quadratic formula. The thing that's nice about this is you've already figured out what's underneath the radical, so you don't have much left to do in order to find the solutions. Okay? Go ahead and do B. Yep, that is 0. Okay? Which means, what do I know about the roots? There's 1 rational. Okay? Okay? 1 rational root. And think about it this way. Okay? Since what's under the radical is 0, the only solution is negative b over 2a. Okay? Sometimes if you wanted to write this, you could say 1 real rational. That would be okay too. All right? Again, in your homework today, there's going to be a part C where it says, now solve using the quadratic. You've already found what goes underneath the radical, so most of the work is already done. All right? Any questions?